In this illustration, we intend to determine the deflection of the model using the Abaqus software and analytical solution. In this question, first, the vertical deflection of point A is calculated using the analytical solution, then point A using the Abaqus software, then the results of the Abaqus software are compared with results gained from the analytical solution. As you observe in this picture, the model includes lever AB and rod BC, and a 450 Newton force is applied to point A. Actually, this problem has been selected from Mechanics of Materials book. Here, the problem can be observed. The length of lever AB is 500 mm and the length of rod BC is equal to 600 mm. The purpose of this problem is to calculate the deflection of point A. I will enter the Abaqus software for simulation. I will click on Create Part. I intend to create a geometric shape of the model. I will select the modeling space as 3D. From here, deformable, then wire and planar. Enter approximate size equal to 2000 and continue. Here first, I will draw a horizontal line and then a vertical line. The length of rod BC is equal to 600 millimeters and the length of lever AB is equal to 500 millimeters. Done. I will enter Property module, click on Create Material. As explained in the book, rod BC is made of steel. I will click on Mechanical menu, select Elasticity and Elastic. The Young modulus of steel is equal to 200 gigapascal. I will enter Young modulus equal to 200,000 megapascal. The Poisson ratio is equal to 0.3. OK. I will click on Create Section. First, I intend to define section BC. Here, I will select beam and the beam again and continue. I will click on Create Beam Profile. Here, select Circular and continue. As explained in the book, the diameter of rod BC is 20 millimeters. I will enter radius equal to 10 millimeters. OK and OK. I will click on Assign Section. Select this line. Done. Again, I will click on Create Section. This time, I intend to define section AB. Continue. I will click on Create Beam Profile. Here, select Rectangular and continue. As explained in the book, the cross section of lever AB is a rectangle with a thickness of 10 millimeters and a depth of 30 millimeters. OK. Here I'll select Profile 2 and OK. I will click on Assign Section, select this line. Done. Select AB section. I will click on Assign Beam Orientation, select the whole of the model, done. Press the Enter button and OK. Here you can observe the model in a three-dimensional form. I will enter Assembly Module, click on Create Instance and OK. I will enter Step Module, click on Create Step. Here, select Static, General and Continue. The analysis will be done in non-linear form. I will enter time period equal to 1 second and OK. I will enter Load Module. Click on Create Boundary Condition. Here select Initial Step. Then select Displacement, Rotation and Continue. I will select this point and done. As you observe in the picture, point C is absolutely fixed. So here I will close all the boundary conditions. In the next step, I'll click on Create Boundary Condition, select Displacement, Rotation, and Continue. I will select this point. As you observe in this picture, point B is not allowed to move directed at vertical axis. So here I'll close the boundary condition of U3 and OK. I will click on Create Load, select Step 1, then select Concentrated Force and Continue. I'll select this point, done. As you observe in the picture, a 450 Newton force is applied to point A. I will enter Mesh Module, click on Seed Part and enter Approximate Global Size equal to 5 millimeters. OK. Click on Mesh Part and Yes. After that, I'll click on Assign Element Type. Select the whole of the model. Done. Here, the element family should be put on beam. OK. I will enter Job Module. Here, I'll save the model. The analysis was done successfully, so I'll click on Result. Here you can observe the deformation of the model. Here, the purpose of this problem is to calculate the deflection of point A. This problem has been solved here using the analytical solution. Actually, first, the problem would be solved using the analytical solution, then using the Abaqus software, and finally, the results gained from the Abaqus software will be compared with results of the analytical solution. Here, we first solve the problem using the analytical solution. To do so, we should first calculate the polar moment of inertia for rod BC. Then we calculate moment of inertia for lever AB, and here you can observe their quantities. In the next step, we should calculate the strain energy due to bending for lever AB. Actually, as you can see, the lever AB undergoes a bending for the sake of the 450 Newton force being applied to it. And here we use this formula in order to calculate the strain energy due to bending. Here, strain energy due to bending has been obtained for lever AB. In the next step, we should calculate the strain energy due to torsion for the rod BC. Actually, rod BC undergoes a torsion for the sake of the 450 Newton force being applied to it. Here we use this formula for calculating strain energy due to torsion, and the strain energy due to torsion has been calculated here for rod BC. Actually, in the next step, we should add the strain energy of lever AB with strain energy of the rod BC in order to obtain the total strain energy. Here you can observe the total strain energy. In the last step, to calculate vertical deflection of point A, we can use this formula. P1 is the same force, that is equal to 450 Newton. U is the strain energy, and X1 is in fact the vertical deflection of point A. In the end, the deflection of point A is equal to 59.82 millimeters. Now, here we intend to calculate the deflection of point A using the Abaqus software. I will click on Create XY Data, select ODB Field Output, and Continue. Here I will select Unique Nodal, then U3. Here, select this point and click on Save As. Here, the deflection having been calculated by the Abaqus software is equal to 60 millimeters. As you observe, the results obtained from the Abaqus software are so close to those of the analytical solution. Actually, the deflection of point A gained from the analytical solution is equal to 59.82 millimeters, and the deflection obtained from the Abaqus software is equal to 60 millimeters. As you observe, the results obtained from the Abaqus software are so much close to the results gained from the analytical solution.